For decades, the skyline was dominated by European engineering. But recently, something shifted. Right now, the 3 largest tower cranes ever built are not scattered across the globe. They are all operating within the borders of a single nation that has effectively established a global monopoly on ultra-heavy lifting technology. We will be analyzing these 3 titans in order of their impact, building up to the largest crane ever built. This concentration of power raises a critical question. How did one country manage to outpace the rest of the world combined, and what does it mean for the future of global infrastructure? Our journey into these titans starts with the XCMG XGT15000-600S. Developed as a joint venture between XCMG and the China Railway Major Bridge Engineering Group, this machine was a milestone that signaled a shift in global dominance. It boasts a staggering rated load moment of 15,000 ton-meters and a maximum lifting capacity of 600 metric tons. To put that into perspective, the total weight of the tower crane itself is 4,000 metric tons, which is equivalent to 100 regular tower cranes combined into a single frame. The 15600S was specifically engineered to solve the old and difficult problems of mega-scale bridge construction: extremely heavy components, massive operation spans, and working at heights exceeding 300 meters. It features a flat-top main tower, a boom auxiliary tower, and a manned elevator for operators. Its primary theater of operation has been the Changtai-Yangtze River Bridge, the world's largest diamond-type cable-stayed bridge. Here, it is tasked with hoisting steel tower segments weighing over 500 metric tons at altitudes where wind speeds and structural stability become lethal variables. The precision required is absolute. The crane successfully handled the linear control of tower column construction at 370 meters in the air. Beyond the raw lift capacity, the 15600S incorporates over 60 core technology breakthroughs. One of the most significant is the world's first 4-bar linkage double-amplitude cooperative operation technology. This allows the crane to manage a 600-ton super rope capacity in limited installation spaces. It has undergone over 2,000 lifting tests and 1,440 hours of non-stop testing to ensure it can withstand a level 12 typhoon in non-working state. The engineering required for the base of this machine is a story in itself. To support 4,000 metric tons of steel, plus a 600-ton load, the foundation must be anchored deep into the riverbed, often requiring dozens of reinforced concrete piles driven over 100 meters into the earth. The logistics of moving a machine of this scale are almost as impressive as the lift. It requires a fleet of specialized transport vehicles just to get the components to the site. Once there, the assembly process is a feat of engineering in its own right, often taking weeks of meticulous work before the first lift can even be attempted. This is a high-stakes industrial operation where every bolt and weld is a point of potential failure. However, even as the 15600S was setting records, the industry was already moving toward even more ambitious targets. While this machine proved that 600 metric tons was possible, a new rival was emerging that would push the limits of crane capacity even further. In the world of heavy machinery, records are made to be broken, and Zoomlion did exactly that with the R20000-720. Known in the industry as the king of cranes, this machine represented a massive leap in capacity, featuring a rated load moment of 20,000 ton-meters and a maximum lifting capacity of 720 metric tons. To visualize its power, the R20000-720 can hoist the equivalent of 500 standard automobiles to the top of a 130-story building simultaneously. The technical sophistication here is unparalleled, integrating 158 novel scientific research achievements and holding 305 invention patents. One of its most critical features is the mobile balancing weight technology. Instead of a fixed counterweight, this system moves the weights precisely in response to the real-time lifting torque, which improves hoisting performance by over 60%. This allows the crane to remain stable under extreme loads that would tip traditional designs, while a heavy-duty split structure reduces the upper equipment weight by more than 20% for easier transport. The R20000-720 has been the backbone of the Ma'anshan Yangtze River Bridge and the Shirzeyang Bridge, the latter being the world's largest dual-level suspension bridge with a main span of 2,180 meters. Operating in the high humidity, high wind environment of the Pearl River Delta, the crane must handle individual components weighing up to 92.8 metric tons. Its intelligent control system features 230 control strategies, providing millisecond response times to ensure that even in extreme wind conditions, the machine remains a stable platform. One of the most impressive technical aspects of the R20000-720 is the structural integrity of its tower sections. Each section is fabricated from high-strength steel that must undergo rigorous non-destructive testing, including ultrasonic and X-ray inspections. When you are dealing with a load moment of 20,000 ton-meters, the tension on the outer cords of the jib is immense. The crane uses a proprietary pin connection system that allows for rapid assembly while maintaining the rigid strength required for heavy lifts. Every moment is monitored by hundreds of sensors that feed data back to an operator who must balance the raw power of the machine with the delicate touch required for precise placement. The sheer scale of the R20000-720 is difficult to overstate. Its jib length and reach are critical when working on bridges that span kilometers across open water. But the existence of these machines in the same country isn't a coincidence. It's part of a much larger, calculated strategy that has left the rest of the world watching from the sidelines. Before we reveal the largest crane ever built, we must address the elephant in the room. Why are all three of these world record holders in China? It isn't just about having the biggest machines. It's about a total dominance of the heavy lifting ecosystem. While Western manufacturers still produce world-class equipment, they haven't matched the sheer scale of the large tower era currently unfolding in the East. This dominance is driven by a state-backed intelligent transformation strategy. In provinces like Hunan and Jiangsu, companies like XCMG and Zoomlion have built among the world's largest and most advanced tower crane intelligent factories. These facilities use robot welding and automated production lines to achieve 100% consistency in structural components. When you are lifting 700 metric tons, a single imperfect weld can lead to a catastrophic failure. China has effectively automated that risk away through high-precision manufacturing. The "why China" question goes deeper into the heart of global economic planning. The nation has moved toward a modular construction philosophy that requires these super cranes. Instead of building a bridge bit by bit over a river, they manufacture massive segments in a controlled factory environment and ship them to the site. This method is faster and safer, but it demands lifting capacities that simply didn't exist a decade ago. While a European or American firm might see the cost of an ultra-heavy crane as a liability, the Chinese industry sees it as a necessary tool for their super engineering projects. Furthermore, the domestic demand is massive. China's internal mega-project requirements mean these cranes are often booked years in advance for high-speed rail networks and bridge projects. They are building bridges with spans that were once thought impossible, necessitating a level of equipment that can handle extreme heights and weights simultaneously. By controlling the equipment, they effectively control the pace of global infrastructure development. When a bridge design requires a lift that no current crane can perform, the engineering teams at XCMG and Zoomlion are brought in during the pre-production phase to design the crane alongside the bridge. This level of integration is unique, It turns the crane from a generic construction tool into a bespoke solution. This industrial concentration has also led to a massive talent pool of engineers and operators who specialize in nothing but ultra-heavy lifts. The knowledge gained from one project is immediately cycled back into the design of the next machine. This rapid iteration cycle is something that no other country can currently match. It's an ecosystem designed for growth, and it is showing no signs of slowing down. The result is a self-reinforcing loop. More mega projects lead to the demand for bigger cranes. Building bigger cranes leads to the ability to design even more ambitious projects. This monopoly of might means that if a country in the West wanted to build a bridge using these same modular methods at the cutting edge, they would likely have to procure the equipment or collaborate with the very nation that currently holds all the records. The current pinnacle of engineering is the XCMG XGT15000-760S. Delivered in 2024, it currently holds 5 separate world records, including the highest rated lifting moment in history, 23,000 ton-meters. Its maximum lifting capacity is a jaw-dropping 760 metric tons. This machine was specifically tailored for the Nansha-Wanlong Bridge in Guangzhou, which will be the world's largest span self-anchored suspension bridge. To handle the immense stresses, XCMG developed a dual-arm frame parallel combination, the first of its kind, and a multi-mechanism 4-trolley 4-hook joint operation system. In testing, the crane successfully completed a dynamic load lift of 950 metric tons, which is 1.25 times its rated capacity, ensuring absolute structural safety. The 23,760S can stand independently at 145 meters, but with just 3 attachments, it reaches a height of over 400 meters. It is equipped with an intelligent control system that allows for remote cluster collaborative control, meaning multiple cranes can work in perfect synchronization on a single project. It also features a remote online diagnosis and troubleshooting system, effectively improving control precision and construction efficiency. This is the future of the industry: massive, intelligent, and operating with a precision that defies its immense scale. To understand the scale of the 23,760S, you have to look at the rope system alone. The wire ropes used for the main hoist are several inches thick, composed of hundreds of individual high-tensile steel strands. The drum that houses this rope is as large as a small room, powered by high-torque electric motors that must provide perfectly smooth acceleration and deceleration. If the load jerks, the kinetic energy involved could snap the jib. The control systems must account for the pendulum effect of a 700-ton load hanging hundreds of meters in the air, using complex algorithms to counteract any sway before it starts. Operating a machine of this size is as much about data as it is about mechanics. The control room looks more like a flight deck, with multiple screens providing real-time telemetry on wind speed, load balance, and structural strain. The level of automation involved means the crane can compensate for environmental changes faster than a human operator ever could. This isn't just a bigger tool, it's a smarter one representing the cutting edge of digital connectivity. The existence of the 23,760S is the ultimate payoff to the question we asked at the start. One country has the monopoly because they have invested in the super equipment required for super engineering. They didn't just build a bigger crane, they built a new way to build the world. Thanks for watching Hard Hat Industries, your source for serious machines doing real work. If you like this, hit like, subscribe, and turn on notifications so you don't miss what's next. Until then, keep your head down and your gear running.